Okay, so for this example, we're looking at making a gear. So we can look at using an Involute profile for the tooth profile on here. So for this file, notice I'm in gear example P2. I'll make P1 available to download via link in the comments. So first thing I want to have a look at is our variables. So if we open this in Solid Edge, we need this to be in Solid Edge 2022. I'll do another video showing how we can do this in 2021 or previous. So here we've got our different options. So we've got our addendum diameter, which is our outside pitch diameter, and then we've got our base diameter on there, and then we've got our addendum diameter, which is the inside of the teeth, bottom surface on there. And you can see we've got different calculations. I've simplified this, so this is normally minus addendum. I've just simplified that to make sure that it works better when we go and change it. I haven't set any limits on here, so if you're used to doing limits, I've just put a comment on there for the pressure angles on there. So obviously I'm just going to leave this as 20 for here. I don't know why that's actually in the wrong box, so I'm just going to go and copy and paste that into there. So it's obviously degrees, that one. When we do have these variables, obviously they do come up with just millimeters on there, but obviously teeth number is teeth number, diametral pitch is 2, and then our pressure angle is 2 on there. So if you do want to go and create those yourself, pause the video here and go and recreate those. I'm also going to make this a little bit simpler. I'm going to go and change base radius to BR just to make that easier when we go and use that later on. So now we've got that open, I'm going to go and just leave this open on the side. So because we haven't got an easy way of going adding these in Solid Edge, I find it nice if we go and just leave this on the side on there. So we're doing ordered modeling on here. So for this, I'm actually going to just do a sketch on here, and then we can go and hide this once we've done it. So I do a sketch on the top plane on there, and then I'm going to choose circle by center plane, and I'm just going to go and create my 4 circles to go and link these onto. So if we just go and create those 4 circles, all starting from the center, and then use Smart Dimension and go and dimension each of these circles up on here. Okay. Notice I've got mine set, so once you place those, you right click on those, mine's set to show all formulas just so we can see which one is which on there. So first of all, we need to set the top one to the addendum diameter. So if we double click on that one, that's going to come up in there, and we can set that to be equals the addendum diameter on there. So we can just go and copy and paste that value into there, and then green tick, and we should see that go and change. Ignore everything's going to shrink because we're doing just a small gear here for a small motor. And if we go and do that for the rest of those, so the second one, I'm going to go and choose equals pitch diameter. Okay, I'm just going to copy and paste it in. Okay, so next one we're going to do base diameter. And then the last one we're going to do the addendum diameter on there. Okay, I'm just going to go and tidy these up. So if we go and look at this again later on, we can see this more clearly on here. If we right click on one of those dimensions and go show all values, we can see that we're getting those values from there. And if we go and make a change to the teeth number, so I'm going to go and change that to 28, you'll see that all those diameters are going to change on there. I'm going to go and set those back to 32 on there. Okay, so once we've done that, if we close that sketch, okay, I'm just going to call this base sketch. And then I'm just going to use Control S to go and save that, and then do a fit on there. Just either double click the right mouse, the middle mouse button, use the fit button, alt right click, or any different fit option on there. So next we're going to go and extrude that. So we're going to choose extrude, choose select from sketch if it doesn't default to select from sketch, choose the outside element on there, and then we're going to extrude that down. I'm just going to go 10 mm on there. Okay. So again, let's save that. So next what I want to do, I want to go and create the curve, the involute curve. So for this, we can't do involute curve in normal sketch, but we can do it in a 3D sketch. So if we go to our 3D sketch command and find our equation driven curve option on there. So notice other systems might have this, but they won't have the Z option. So they'll have this in the 2D environment, but they won't have the Z option. So what we need to do is go and find different options. So if we go and find our involute of circle on there, that's the option that we want to base our option on. Our parameters, I'm just going to set that between 0 and 1 on there. And then we need to go and do our equation. So we need to go and add our BR, our base radius on there, which will be the start point of the curve on there. So for this to work in here, it's slightly different to other options. So we're going to do a open bracket, open square bracket. We're going to pop our variable in, BR, close square bracket. And then we're going to go times 1000 and close that bracket. And we're going to do the same for the other one on there. So open bracket, open square bracket, BR, close square bracket, times 1000, close bracket on there. And then if you use the tab key to go and see that output, you'll see that we've got that output for that gear starting from the base diameter on there for us. We can then click OK. Just to make sure this works correctly, I'm also going to choose the little lock icon and click on the line that we've just created so it goes black. If we haven't got our relationship colors on, we can turn those on up here. We can then go and close that. And if we need to go and, I'm just going to change that to involute curve, and I'm going to change that to base revolve on there. Just makes it easier if we're going back to something else now. Okay, so next we're going to go to our sketch command and we're going to choose our front face. Make sure it's orientated the way that mine is on there. So obviously use your key orientations in the prompt bar at the bottom if it doesn't come that way. And then we want to kind of zoom in, so we've got that pretty much on the left hand side of the screen and that corner up in the screen up there. So what we want to do first is use a Projector Sketch, and we want to just stick with the default settings on there, and we want to go and choose this element. If it doesn't work, try the different options on there before we get that to work. So I find either single wireframe or wireframe chain will tend to work on there. And to make sure that that's also connected properly, I'm going to just connect the endpoint to the endpoint underneath. If we don't do that, if we click on that line, notice that's going to kind of drag down. So by using that connect we can connect that to the endpoint, and then that to the endpoint on there, and it should then go fully defined. If it doesn't connect, just go and drag it across and then reconnect it using the connect button on there to make sure that then becomes fully defined on there. Okay, so we should end up with our little link symbol, our square endpoint connect. If you do get any other ones, just use the quick pick option to go and make sure that we haven't got any of those other options that we don't want on there. So notice we're doing this as a sketch. So what we want to do on this sketch is create a enclosed region that is going to allow us to create half a cutout. So I want a line going to the center on there. Okay, and then I want another line coming back to the base diameter on there. And then I want another line coming straight out. I'm just gonna create this so it links to there. And it goes to there. If you do create relationships that we don't need, so I want to remove that one, and I want to go and make sure that we've got a colon here between those two instead. And then I'm going to use my smart dimension and use the A key to change that to an angle dimension, and that's then going to give me my spacing on there, and we can go and link that to the appropriate angle at the appropriate option that we need. Okay, so we're going to go and link that to tooth spacing on this one. So if we copy that and double click on our angle constraint on there, and that's going to equal tooth spacing on there for us. Okay, I've actually made a slight mistake on there, but I'm going to go and change that in a sec. So our tooth spacing should actually be to a line that goes to the intersection point here. So I'm going to create a line from that intersection point to the center point on there. I'm just going to turn a lot of these into reference points on here. So I want that to be a reference point, reference line, reference line, reference line. And then I want to go and change this angle. So those who know the magic Alt key, we should be able to use the Alt key to go and change where this connects to. So if I go and drag this over here, we can go and move that so it goes and connects to that other line instead on there. So click on the dimension, press and hold the Alt key, go and move that to there. If it won't let us do that, it might be easier just to go and recreate it. So I'm just going to do my smart dimension, use the A key, and go and make that equal the tooth spacing again. Fully define this, normally fine, we just need to do a horizontal vertical over there just to get that fully defined. And then the last thing, we need to finish this profile. So we've got a open profile for our cut, which we can't support. So what we're going to do a arc by center point, choose the center, and then we're going to choose our arc. So I'm going to use the E key to start from the end of that line. Okay. And then again, I'm going to go and choose this line to go and end it on, and I'm going to choose the E key on there. Solid Edge can do this weird thing where it kind of starts to go and create it the wrong way. So in that instance, when we do our arc by center, it might be easier to go and start it from the bottom one. That will then start to go up, and then we can hover over that one and use our E key to go to the end on there. And that's going to go and create that line. So we've now got our region on there. So we can check we've got our region by doing, so we can normally do like an area check on there. We can check our full region because the area tool is going to go and create that area for us. Okay, so now we've done that, if we close that sketch, And I'm going to call this half tough cut. And then we're going to just use our normal standard cut command, choose select from sketch, choose the closed profile on that, and then do a cut that goes all the way through on that component. Next step, we're going to mirror that feature. So we're going to choose mirror, choose that feature, accept, and then choose the plane, the straight plane on there. That's going to go and create that cutout for us on there. Okay, next step, we're going to go and create a pattern. So we're going to choose our pattern command, choose the features. So I'm just going to choose those from the feature tree just to make it a little bit easier. And we're going to pattern on the top plane. So within the pattern, just make sure you're on circle up here if we're not. So choose a center point, choose a point. I like to choose the end of that line. Little blue arrow, make sure that's pointing in a certain direction. And then go and set the count to the same as the count we've got on there. So I need to change that to 32. And then close. And we've then got our sketch-driven circular pattern showing those teeth in there. So what I need to do now in the variable table, I just need to expand the pattern and make sure the value that we've got in there is going to be equal to teeth number. Okay, so if we go and change our teeth number on there, so I'm just going to go and change that to 30. We should see a live rebuild of that part on there for us. Okay, so I've made a slight mistake. I should have actually taken the cutout to the inside. So not on purpose, but just like real life. So I'm going to go and just recreate this cut. So you can see I'm just going to move this angle dimension out of the way, just so that's not in the way. So this line that we've got on there should have been, so for this we actually should have created an additional little line that goes to there. So you can hover over those two lines. It should then allow us to go and pick up the intersection point on there, or we can use our I key to pick up that intersection point. And then we can also, so there I'm also going to go and use a arc command. And again, I'm going to go and pick the intersection point on there. And that should go and find the appropriate intersection point that we need. And then I'm going to go and take that line back to there. Notice we get highlights of orange showing that that is linked to those. So if we close that, we might have to redefine our cutout. Hopefully Solid Edge isn't going to ask us to go and redefine our cutout. And we've corrected that little issue. Okay, so that's it. There isn't a huge amount, so these values we can go and change things. So we can go and change our pressure angle to 22. That's going to go and make that change on there. I'm going to go and change that back to 20. We've got our teeth number on there. There would be a limit what we could go and change this to. So if we go and change that down to 24, we should be okay on there. If we change it up to 40, not 70. Let's try 70. Solid Edge seems to like 7 rather than 4. There probably should be set a limit. This probably will go wrong when we go this high. We can see that we've got a bit of a change. Not quite suited to that kind of change, so I'm going to go and set that back to 40 on there. And we're going to get that live rebuild as we go and make that change. So if we did put two of these together and we created a surface on the pitch diameter and we did a tangent between those, we should get a perfect rotation between those parts. Okay, so here's that example. So we can see we've got these parts on there. I've added some motors on here, so I've added a rotational motor, and then we've got a link between these linked to the teeth values, 25 and 35 on there. So if we do a play on there, and if we just double check, we've got our animation on there. If we go to our animation options, I've actually got check interference running on there as well. And if we do a play on there, we can see that we've got those moving without any issues on there. And if we zoom in, just go and restart that, you can see that we've got those gears are perfectly meshing. I go and slow that down. I'll make that a little bit better on there, so we can see that that is meshing much better on there. And I could also possibly go and change my settings, go and change that frame rate. Let's go 90 on there. So you're going to see that quite smooth with a real nice gear mesh between those with those appropriate settings on there. Okay, any questions or comments? I just need to say thank you to Joko Engineering. So this was based on one of their videos. Made a few little changes to the to some of the gear ratios to make sure they work if we change it larger or smaller. So quite a nice little example, hopefully. Okay, let me know any comments. Like and subscribe as well, please. Thank you.